Alrighty, ladies and gents, this video is about how we perform a hypothesis test of the mean, where the population standard deviation is known. Sorry about the typo. We're going to do this in the calculator. So this is the video y'all been waiting on. How we do this thing in the calculator. Alright, so yes, whenever we know the population standard deviation, we are going to use something that's called a z-test. So, as we've been talking about for a little while now, when I know the population standard deviation, it's the z-distribution. When I do not know the population standard deviation, it is the t-distribution. So how do I get to this z-test? Well, I'll show you really quickly in the calculator. Let's clear this out. If you hit your stat button, and if you migrate over to the test menu, hit your right arrow, right there, number 1, z-test. So this is the hypothesis test we'll be using for for this lecture. The input, if you remember confidence intervals, the input will either be data or stats. If you have a list of data somewhere, you're going to select the data. If instead you have the stats instead of the actual data, then you use the stats option. Okay, so let's actually get into an example here. A paving company wanted to determine the average width of single care driveways that have been that they had been paving had what? A paving company wanted to determine if the average width of single care driveways that they had been paving had decreased. They're trying to test if something decreased. The company randomly sampled 10 single car driveways that they had paved recently, and the result gave them a sample mean of 11.7 feet. Historically, the driveways paved by the companies are normally distributed with an average width of 12.2 feet and a standard deviation of 1.3 feet. Assume the population standard deviation, is equal to the historical standard deviation. So, basically, we know the population standard deviation. We can do what is known as a z-test. Okay, use a calculator to test whether the width of the driveway that the company has paved has decreased recently. Okay. So once again, I briefly mentioned in the last video, but once again, there are conditions that are necessary for a hypothesis test. So the conditions are for a z-test must be either your sample size needs to be greater than or equal to 30, or if it's less than 30, you need to have somewhere written that the population is normal. Okay, so our sample size for this example is, where you at, mister? Is 10. So there should be, they don't have it here, so it's their mistake, but there should be a statement in there that says, okay, we'll assume the distribution of these driveways is normally distributed, because that's the only way we can do a z-test. But let's go ahead and assume that the conditions are met. Okay, so now let us calculate or do this hypothesis test. Let's grab a different color. So we're trying to test if the mean has decreased. That's the key word right there. So our hypotheses, always the first step, is that we need mu to be less than the historical value. I go back to what I said. They did tell us that they're normally distributed. So that's very important. So yes, we can definitely do a z-test. All right. So historically, the driveways paved by the companies have an average of 12.2. So we're trying to see if the average width has decreased. So our hypotheses is either mu will be less than 12.2, excuse me, or the mean equals 12.2. Remember, that's our kind of our convention for writing H0. And HA is our claim. And honestly speaking, most of the time, HA will be your claim, most of the time. So now that we know that we have a a population standard deviation and we're testing one mean, we're going to do a z-test. And what the z-test does in the calculator, what it does is, if you watched the last video, we went through the whole process of finding the test statistic and then use that to find the p-value. Well, look, as long as you know the following values, we can plug all this into the calculator. In fact, let's go to the calculator. And we're under z-test. And for this example, we do not have the data values. Okay, what I mean by that is we do not have all 10 cars, okay, or driveways in a data set somewhere. So what we have are the statistics. So let's change over to statistics. Press enter, and now what we need is the mu naught, the sigma, the x bar, and the n. So let's grab those from the problem. Okay. Mu naught, let's do a different color. Mu naught always comes from your hypothesis. So mu naught for us will be, well, the 12.2. Okay. Think of that 0 as being h naught, whatever you want to do, but the mu naught comes from the hypothesis. We need our population standard deviation, which they told us grab the historical one. So standard deviation of 1.3 feet. We need an x bar, that is our sample mean. It's not the 12.2. The sample mean was 11.7. So x bar is 11.7, and we need a sample size n, which is 10. All right. So now we just simply feed all that information into our calculator. Okay. The mu naught was, what was it? It was 12.2. Let's see, the standard deviation was 1.3. X bar was, I believe, was 11.7. Let me double check that. Yep. And our n is 10. Very important distinction here at the very end is that the calculator needs to know what type of test should you perform. Should you perform a two-tailed test, a left-tailed test, or a right-tailed test? That is what your calculator is asking for. Well, remember, this comes from the HA if you watched the previous video. And our HA is a less than, is a strictly less than. So that means that we're going to perform a left-tailed test. So make sure you go to the left tail, which in our case is the middle option here. Push enter to select it. Excuse me. Go down to calculate. And here we go. If you are asked for the test statistic, our test statistic will be a negative 1.216 if you wanted to go to 3 decimal places. So the output from the calculator shows you your test statistic. And most importantly is the p-value, and that's what the p is right there. So to 3 decimal places, our p is a 0.112 if I round out to 3 decimal places. Okay, so our p-value ended up being a 0.112. Now I want to do to complete this, let's go ahead and make a decision. And so now it becomes just like we did in the last video. To make your decision, you take your p-value of 0.112 and you compare it to your alpha, which they tell us use a 0.05. I'm going to add an extra 0 because it's legal. We could do it. How does 112 compare to 50? 112 is greater than 50. So our p-value is greater than alpha, which means we should fail to reject the null hypothesis. Which means what? What's the interpretation? Because we are failing, there is not enough evidence. So there is not enough evidence to support the claim because the claim was an HA. Okay, watch the previous video if you forgot how to make that interpretation. But there we go. So as you can see, the calculator greatly improves the time it takes for us to calculate the p-value. But you still have to know how to write your hypotheses. You have to understand what goes where, and then you have to know how to make your own interpretation. Okay, one more. Drew wondered if the average age of students in his AP Stats class in his high school is under 18. So Drew wants to know if the mean age of students is less than 18. He randomly selected 10 AP students in his school, and the data set is given below. Using the information from a previous survey, he has concluded that the population standard deviation for his age group, for the age in this AP Stats class, is 1.44. So we know the population standard deviation. We need to do a z-test. Assume the ages of students in this class are normally distributed. Okay? We need that normal distribution because our sample size is smaller than 30. Remember the conditions for hypothesis testing. Okay, I left this part out, sorry, but let's go ahead and assume alpha is a 0.05, and let's perform a hypothesis test for this scenario. First step, write your hypotheses. We are testing if the mean age is under 18. So we're testing if mu is less than 18. This is the claim. Otherwise, the mean equals 18. That'll be our H null. The claim for this is an HA. All right. Our population standard deviation is a 1.44. We're going to need that in a minute. And so now for this, we actually have the data set. So what I'm going to do is I'm going to take those 10 scores and we're going to plug those into the calculator under L1. So here we go. See if I could do this. How to get to L1? We hit stat and we select number 1 edit. If you have junk in there, remember go up to L1, hit clear, and then enter. Gets rid of all the old junk. Here we go. I believe the data values were 17, 16, 15, 17, 17, 18, 18. What were the other ones? 19, 18, 17. Okay, and we can see that we have now 10 entries. You can see it by the L1 of 10 there. All right, so we have 10 entries. Now, here we go. We're ready to perform our hypothesis test. The standard deviation, the population standard deviation is known, so this is a z-test. So go to test, number 1, z-test. This time we have the data. Go to data. Okay. What's our mu null, that mu naught? Mu naught comes from the hypothesis, so our mu naught is 18. Mu naught is 18. So data, we go down, this is 18. We said the standard deviation was 1.44. List is L1, is asking for what data set do you want to perform the hypothesis test on. Frequency, always keep that as a 1. And once again, it's asking what tail test is this? This is a left-tailed test. Left-tailed test. It is selected. We go to calculate. All right, once again, if you're asked for the test statistic, it's a negative 1.757 if we round it 3 decimal places. Our p-value is a 0.039. 0.039. So the p-value is 0.039. And you guys know the drill. Same song and dance. To make a decision, we take that p-value, compare it to alpha, which is 0.050. 39 is less than 50. So we are in the case where the p-value is less than alpha, which means this time we should reject H null. And what does that mean? That means that there is enough evidence to support the claim. So yeah, based off our analysis, we've decided, yeah, the mean age in AP stats is less than 18 years of age. All right, people. See you guys in the next video.